And the stuff that you'll follow along with here, you'll basically end up with like sort of a small web-based map application of your own by the end of following through these resources. So broadly speaking, I'm going to try and get people interested in version control and collaboration with a GIS focus using GitHub. So this is something that has not been crazily explored in GitHub yet, but they definitely, the owners of the platform definitely want to become more of a thing. So these are the steps we're going to go through fairly quickly, I think. And I apologize if I seem rambly at any point, but there's so much to talk about with this that I'm going to try and really narrow my focus. So essentially, why should a GIS person be interested in using GitHub? Why would you want to manage data with something that we think of as traditionally like a software developer's tool? It's for managing code. You currently might have your data in SDE or PostGIS or Oracle or any number of possible locations, and I think there are a bunch of reasons why that model can be improved on. First of all, it's free. That is unequivocal on GitHub's part. They're very, very interested in promoting open source software development and open data. So as long as you are not trying to make your data private, and I mean private in the read sense, like your data is automatically private in the edit sense. But as long as you're not trying to make your data private, no amount that you want to put on there will ever be charged. So it's free, it's automatically backed up. This is sort of the quintessential cloud backup service for your data. And something that is basically of great interest to me is the idea of versioning. So just going to keep checking these. Okay. So versioning is something that you folks might have experience with through, I think there are some Esri services that offer something like this, but the essential idea is that you have a copy of your data at every state of its progress through and life. So if you make an edit to a node, that is saved somewhere and retrievable as an edit. And the state that it was in before that edit is also retrievable. So the idea is that you can't screw things up. You can't break things because you can always just go back to the previous version. You can always go back to when it last worked. And versioning, in this case, this is just a quick GitHub preview. What you're seeing is a highlighted polygon and the way that it looked before an edit occurred. So this is just an edit to a data set that I included in this tutorial. I wanted to make this traffic island parcel a little bit bigger under the assumption that there's some stuff changing on the ground and it needed to reflect reality a little bit better. So that edit is saved in this particular GitHub state, which is called a diff, which basically just means the difference between one state and another state. Also, what's particularly useful about GitHub is that it's collaborative. Now, this is something that is fairly easy to understand in the software development context. You can, if you're building a program and you have two developers, one developer commits a bunch of code to the GitHub central repository. Another developer commits a few changes to that repository, and the first developer can immediately get those changes, make more, continue to hand it back and forth, and you can actually edit things simultaneously in this way. The idea here is that many people working together are going to have, if they have a limited amount of friction on their collaboration, then they'll be able to get much more done. This is just a screenshot of the way that we at Faraday work on a particular repository in our company. This is a program that does our front-end mapping, and you can see over time the number of code commits that have been made by each person. So you can get a general sense of their contribution. You can also see that I'm totally getting lapped by these other three guys and should probably commit some more code. But in general, the idea is that you can collaborate very effectively using GitHub. And that is true for Geodata as well as for software development code. So getting set up is fairly simple. you just sign up for a GitHub account, and if you're following along in this link, you'll see that this is actually a link to the GitHub sign up page, which looks like this. Very simple software as a service model. You just get your account and you're off to the races. It's actually not the only thing that can make GitHub really work for you, but that's definitely the only thing you need to do to get started. Something else that you might want to do is install the GitHub app. Now this is actually a really effective way of avoiding code completely. It's something that they built for Mac and for Windows. The workflow is very similar between those two, so I'll be using the Mac version. Windows users, you'll still have a general idea of how it works, but the essential idea here is that when I, as a software developer, am working with GitHub, it's mostly at a command line, at a console. It looks very codey, and that is a particular way of doing it with a certain amount of efficiency behind it, but I also recognize that having the user interface is really, really useful, really lowers the barrier to entry. So I would recommend you install that. These are links to get the Mac version or the Windows version. And obviously, install when you have time. It might take more time than we have here. So let's take a look at getting a code repository up, and in this case it's going to be a code repository that has data in it. So this is a link to a repository that I've set up for this demo. Now when you go to GitHub, I should start back a little bit here. When you go to GitHub, you have a home page. So this is my profile. You can see the repositories that I've worked on that are popular. You can see the repositories I've worked on that I contribute to most often. And there's a general sense of statistics here too. There's when I commit and how much. The organizations that I'm a part of are down here. Faraday, my old company Geosprocket, and Code for BTB. And then there's just sort of a feed of what my activity has been. This is very useful day to day in trying to sort out what changes I've made and what changes others have made. The repository we're going to look at, though, is this one. So VCGI Demo 1. This is pretty simple. It's got a folder with some stuff in it, in this case some images. There's a web application, and then there are 3 types of geodata. And we'll get to those in a second. Now when I say fork this repository, this is a model very popular in open source software development, wherein you grab somebody else's code, make a copy of it for yourself, and start working off of it. You still have the option to grab updates that are made to the original. You have the option to contribute back to the original, or you can just make it entirely your own and work with it in a solo fashion. So you would hit this button, which is fork up here, and then it will create a repository in your account, which is called VCGI Demo. It'll just be your username. So then you would sync it to your computer. The idea here is that you want to have a local copy of something, and you also want to have a cloud copy of something. You keep those synced very frequently, sort of like constantly hitting the save button with ArcMap. You never know what's going to go wrong. So the local copy is where you're going to work, and then you're going to sync that to the cloud copy at the GitHub site. To get that local copy, once you've installed the GitHub app, just hit this big clone in desktop button, and then it will create a copy for you locally. And just to show you what that looks like, here is the GitHub application. You can see I've got a whole bunch of repos here. Sorry, repo is short for repository. Somebody digitally throw something at me if I say that again, because I realize it's shorthand and there's already a lot of shorthand flying around here. The particular repository we're working with is called VCGI Demo, and for each of these you can see all the changes that have been made to it. So over time I've added some data, I've changed a few things about the simple web application, and what's key to look at here is that you can see at the moment there are no changes that have been made to the application. As soon as I change a single if I edit a single node on one of those pieces of geodata, it's going to show up here and prompt me to commit that change to the cloud. So it's a very effective way of keeping you updated. So once that data is in the cloud, once you have your own copy of this repository, you can preview the data. GitHub has gotten very good at making good visualizations. And in particular, once you have some geodata in a repository, they have ways of showing you how it looks. So you can see this is just a collection of parcels at Morristown Corners. And they have all the attribute data that was committed with them. This is just geodata that I got originally from VCGI. And it's in a fairly simple preview window here. So we have to talk about formats, and I apologize. Everybody's probably got more formats than they want to deal with in the course of their daily lives. But whatever your favorite format is, you can get it into a format that will work with GitHub. These are some examples of how you would do that. There's a site called Ogre, there's a site called Shape Escape, and a site called GDB Flee, all of which will take your shape files, your geodatabases, your PostGIS data dumps, your KMLs, whatever, and convert them into one of the favored web formats for geodata, which are Geo JSON and Topo JSON. For this demo, we're going to focus on Geo JSON. But if you have a shapefile you want to add to a repository, go to one of these sites first and convert it. As we go through this, you'll see some of these are links for extra information. This is just some background on what GeoJSON and TopoJSON are, why they're particularly suited to web mapping, and why GitHub supports them. But in this case, you basically, if you think of shapefile as the lingua franca of GIS, GeoJSON is that basic mapping unit for the web. So we've taken a look at some data. We've created a repository with data in it. Now we can edit some data and start keeping track of those edits. Look at the versioning capabilities. So this is sort of dependent on the file size of the data that you're using. So if you have what in the GIS world I know is teeny tiny data, like less than 8 megabytes of GeoJSON, or frankly less than 5 megabytes of shapefile, then I suggest you use Geo I0, which is a website that is basically built for the editing of GeoJSON data in a browser. I recommend this because you can do it from anywhere. You don't need to be on your desktop. You don't need to have access to any desktop GIS software. It is very simple to use and edit with. Just as an example, I'm going to open up some data. So I'm going to open up something from that repository. Let's take a look at these roads. So you can see there's all the vector data that I've added in there. I'm going to go down here and take a quick look at this. It looks like there's just a little cutoff there that hasn't been included, so I'm going to add it. So that has now been added to the GeoJSON. I'm going to save it as GeoJSON again. Actually, I'm just going to overwrite the original because GitHub is doing the versioning for me. And now that is down and available to use. I haven't yet put it into the GitHub repository, so I'm going to do that next by going back to the GitHub app. And you recall that we were looking at an interface that showed changes, and there were no changes at that point, but you'll see now that it has picked up some changes have been made, and changes in particular to this file. So I'm going to say road cutoff added. Adding a message with each change is super useful for when you eventually do screw something up, as I do constantly, and need to go back and figure out where that was. So I'm just going to hit this button that is commit and sync. And then that's going to push all of that stuff up to the web where we'll be able to see that change. So let's go back to that and look at that file. The roads file was here before. It's here, then mind you, we're in a web browser looking at this again. And you can see that that really horribly digitized cutoff has been added into the web version of this repository. So it's basically, it's sort of functionally instantaneous getting those updates to the web backed up and versioned. A way that you can look at the changes of this, and this is something that's particularly useful, is checking out the change sets. So this, hopefully, if I did this correctly, is going to show a very simple difference between, so like the original thing that I showed you where I edited a parcel and there was a slight difference, this is going to show you the difference here. So yeah, you can see that based on this highlight, you can see that that has been added. There's also, you know, if you have more complicated data, you can look at it with a slider. So here's the after, there's the before. That little cutoff has been added. And this is crazily useful if you're looking at data that somebody else has added and you don't particularly, you know, whether they've sent an email with the description of what they've done or whether they didn't tell you at all, you can get a very clear sense of what has been edited, when, and how much. So this is great for auditing data that needs to be sort of in constant rolling updates. I've talked about using this for parcel data in the past, and I know there are, you know, limitations and concerns there, but being able to see every change and being able to get a visualization of it is terribly useful. So that was an example of how you would you'd update a file that was less than 8 megabytes. If you want to do something larger, you kind of have to do it in the desktop. In this case, I have Quantum GIS installed. There are plugins for ArcMap that will allow you to edit Geo JSON directly as well. I actually need to dig those up and link them because I don't have them yet. But basically, between 8 megabytes and 100 megabytes, you want to be doing that on the desktop. Now, the reason that I say it's 100 megabytes is the cap is because that's actually the limit that GitHub imposes on any updates. So if you have you know, 150 megabyte geotiff that you want to push up to the web, you need to chop it up. You need to tile it. You need to do something to subdivide it. And I realize that that is a limitation, and we'll talk about that in a bit. But to quickly look at how you would edit something using Quantum GIS, here's our same area. I'll just add one of those files from the repository. Let's see. Yeah, I'll try the parcels again. So there they are. Again, this is the local copy. So these changes are not going to immediately show up online. I have to commit them. But I'm going to assume that this is some sort of parcel error. I know, completely unfounded assumption. I'm sure the Morristown, let's see. I'm sure the Morristown folks are completely accurate on this, but I'm going to actually sort of awkwardly save this as a shapefile so that I can edit it. And then I'm going to edit that. Let's see. Just going to move that node out of the right of way under the assumption that was an error. I'm going to save that change. And I'm going to save this as GeoJSON. I'm going to overwrite that previous file again because the versioning is taken care of by GitHub. And then all the other defaults tend to be fine here. It's going to hit OK. And then we'll go back to the GitHub application and see if that edit was picked up. And indeed, there's the edit. So we'll commit that and sync it. And you can see these are just two different workflows for basically doing the same thing for editing data that is hosted on GitHub. The collaborative part of this I am actually not going to get into, but just to give you a quick overview, the organization structure in GitHub allows you to create an umbrella organization. So in the case of, say, VCGI, you would have an organization called VCGI to which a bunch of employees would belong. So Leslie would belong, Mike would belong, Steve would belong, and each of you guys would be able to pull a copy of this data, of this repository locally. You would be able to make your edits and then commit those edits, and they would automatically be merged in GitHub. You can even do those simultaneously, and it's very rare that any conflicts occur. The power of that, obviously, is that when you have lots of digitization going on, lots of editing, lots of analysis, all of that can happen sort of in real time, and everybody can work on the same project. You don't have to do that sort of constant handing off of the single zipped shapefile. So the last part that we're going to get to, and actually I might be running through this kind of quickly, which would be great because there would be time for some questions, is the fact that GitHub is built for the web. It is on the web, it is of the web, and it allows you to very easily launch an application that is backed by this data. When we think of data feeding into a web application, there are a lot of complicated ways that we can do that. There's, ArcGIS for server, there's ArcGIS Online, there's, a home-rolled version of GeoServer using PostGIS, there's, any number of possibilities, but what GitHub allows and sort of makes simple is the idea of just having all of your stuff in the same repository. So you have your data and you have your application sitting in this repository, and then you just make a website out of them. And GitHub hosts the website for you. So GitHub Pages is a very, in the scheme of web design, is a very simple way of hosting websites for free. And in this case, you can see there's a repository, or there's an application that came with the repository. This index.html thing. That is automatically going to create a website. So once you've published your updates to this repository, you're comfortable with where the data is, what you want it to look like, you would basically just create a branch called gh-pages. And the way you do this in the GitHub application is fairly simple. You go to the branches of your repository, and from the master branch, you just hit add, and then you would type in gh-pages, branch, and then publish. You can see I've already done that here, so I'm not going to do it again. But once you've done that, GitHub magically detects that you've created a GitHub Pages page, and it will serve that to the web at a URL that's equal to the repository. So just to see what that looks like, this is VCGI-demo1. The location of that application is going to be at my username at GitHub, at github.io /VCGI-demo1. And here is a very simple web map. Not a whole heck of a lot going on here. It's just got a simple base map, but it also has access to the data that we put into it. So up here you can switch it over to a satellite base map if you so choose. You can add any layer from the data that we've been working with. So the roads layer that I made that little edit to, hopefully that edit will be here. Yep, there it is. And this is, a public-facing website, so you can share this link with clients, with stakeholders, with whoever would be interested in it. And you can see that an edit that I made, 5 minutes ago is already available. It actually is available instantaneously as soon as you commit any of your changes. You can also see property boundaries, and those are polygons. And this is, I should probably give a little bit of context for this, but yesterday I asked Jarlath from the Spatial Analysis Lab if he had any handy drone imagery available, because I know he's been flying the SenseFly around on a bunch of different client jobs and collecting some really cool imagery. And within that 100 megabyte limit that I talked about, you can totally include imagery. That basically for the web, that means you want to have tiled imagery, and I won't go into how I tiled it, but this folder here, Mo Vegas, as the locals will occasionally call Morrisville, you can see that I've got a bunch of subfolders, each of which is the zoom level of a bunch of PNGs of imagery. So this is the drone imagery, chopped up, turned into tiles, and basically organized in such a way that this web application can figure out where it is. So if I add that information, then you can see the overlay is immediately available. You can sort of see the differences between the underlying aerial imagery and the new drone imagery. It looks like they were building a bit of a spare lane here. I think that might be Route 15. And you can see there's all sorts of construction going on around the area where I made that edit to the road. This is particularly helpful in the imagery sense because it's not cheap to serve imagery typically. You have this sort of like overhead involved in serving a satellite map of the world like this. This is being served by Mapbox, and it's not free. It's they charge a certain amount to allow you to use this. And if you use Google's map services, there are terms of use and rate limits and things like that associated with it. But if you own the original imagery, you can turn it into a tiled satellite map service for free because GitHub will host it for you. And again, this is when I turn that layer on, that information is coming purely from this folder. It's basically grabbing things out of the repository. So the data's in there. It's freely available. It's collaborative. It's all there, and it's being served for free, which I still a little bit mind-boggling for me. I'm still trying to wrap my head around it. So there's a lot of potential there. There are also limits to that, and GitHub is not a perfect replacement for your geographic information system. It lacks easy access to geoprocessing tools because you can see the same things still have to happen. You need to bring your data locally into your computer locally. You need to make edits to them using a desktop GIS platform. You need to resave them and commit them back to the cloud. Since GitHub has already added things like web previews for vector data and web previews for raster data, it is my hope that at some point they start thinking about baking in some basic geoprocessing, buffer intersection, the standard bread and butter of what we do. But for the moment, that is a limitation of the platform. You can't do everything on the web. So scale is definitely something that GitHub is not built for. When we think about 100 megabyte data set, it's not that big for GIS users. I'm trying to think of a VCGI example. If you were to grab, even a dozen towns parcel files, you'd already be over that limit. So the the idea of a big monolithic data set is not something that works with GitHub's model. And they're actually, if you follow this link, there's a good essay by one of their data folks on why that is. But basically it's because the web doesn't work that way. The web doesn't want a 50 megabyte file to come into somebody's browser before they can start working with it. The web works in a very sort of pint-sized segmented way where, and tiled maps are a good example of that. Instead of loading up the 10 megabytes of imagery that you could see here in a 1 meter geotiff, it's just loading a series of tiles, and probably about a dozen of them in total, that are each very digestible by a web browser. So the way the web works is to chop things up and to serve them only on demand. And that is a bit of a paradigm shift from the way that we think about things in GIS. So the last one is Buyin, and my completely rambling tutorial here is probably not assisting anything, but the idea that we can get people, we can get government information managers out of what is a fairly comfortable silo and get them to start working with something that is more applicable to the broader web is a heavy lift. Like the idea that this is just going to become the workflow for a town's GIS manager is, it's a bit far-fetched that it's going to happen quickly. I would like to think that this is a credible alternative, and I'd also like to think that it's a very future-oriented alternative. What is really nice about using GitHub for this is that it is free and it always will be. That's baked into the terms of service. The openness of it is I guess if you can think of it this way, it's sort of the price you pay for that $0 price tag. The sense that you want your data always looking outward and publicly available is something that may take some time to get used to, and I look forward to having that conversation with anybody who's interested, because it's something that makes things a lot easier for anybody interested in transparency, makes things a lot easier for anybody interested in outreach or accessibility, and yeah, I'm gonna end my rant there. So sweet, still a little bit short there. Thank you guys so much for listening. If you have any questions, hit me on Twitter or send me an email. At the moment, I would totally hear any questions if anybody is in fact still around to ask them. Leslie, are you still there?
I am. Can you hear me?
Yes.
Oh, good. I apologize, everyone, for getting all flustered before when I suddenly couldn't hear Bill. I didn't notice that you were all telling me that you could hear Bill.
I didn't notice that either.
Yeah, so anyway, sorry about that. So yes, we do have some questions. And actually, Bill, you might be able to see them since I made you an organizer.
Oh yeah, let me look here.
If you look over in your panel, there might be a questions section of your panel that you can open up and look at.
Got it. Okay.
Skip over all. Yeah.
Thanks, Dan. Thank you. Thanks, Joanna.
27
okay.
people.
Somebody said ha. Where?
Yeah, I think that was
a tiny arrow?
Triumph when you did something really cool.
Okay, so I can just run through these as quickly as possible, I guess. Does Geo JSON I0 support multiple projections? It does. It actually supports a lot more than I showed. The open file thing will actually take it'll take KML, it'll take CSV with a lat long column, it'll take Geo JSON, it'll take zip shape file, it'll take wow. I mean, it actually takes a bunch of stuff. And then the projection of any of that is automatically detected because on the back end this is running the same projection engine that is fairly common in the spatial world of OGR or GDAL. So if you have something that's in state plane feet, it's going to detect that and bring it in. The thing that might take a little bit of getting used to is the fact that GeoJSON is sort of a natural fit with WGS84. So any coordinates that you see in GeoJSON, any functional coordinates I should say, are going to be expressed in lat long. And something that I like about that is that it makes GeoJSON very literate. You can, if you have a sense of coordinates, you can look at it and sort of immediately tell if something is wrong. So yeah, hopefully that answers the projection question. Is it not possible to edit GeoJSON files directly in QGIS? Good catch, Matt. It is not. I think that is something that they're trying to build support for, particularly since Geojson I0 makes it, fairly straightforward. But at the moment, QGIS, like ArcMap, is built to edit shapefiles. And so you caught my little dodge into a shapefile and then save back into GeoJSON there. Question for Q&A. It looks like they're doing something similar in Bitbucket. Worked fine at a technical level, but Bitbucket terms. Yes, Bitbucket is a bit different. I know they offer private repos for free. It's a bit of a different model, but GitHub does allow data storage on their site. So they support with Preview a whole range of stuff, including I believe PDFs, TIFFs, certainly anything that sort of their text composition language of choice is Markdown, and you'll see that throughout GitHub. But it's sort of like a very simple formatting dodge to let you avoid using, Microsoft Word or whatnot. But all of those things can also be stored on GitHub. They just might not be useful to you in the web version of GitHub. You'd have to, bring the changes and bring the local version into your computer before you can work with it. Hopefully that answers the question. So if we chop the data in less than 100 megabyte packages, we could host unlimited amounts of data in GitHub. Somewhere at GitHub, like if Ben Balter is listening to this, he's frantically waving no, don't do it, but I am going to say in theory this is correct. The limit on 100 megabytes is, it's not on repositories, it's on commits. So if you made a series of 99 megabyte commits, you could theoretically get around this. There are no stated limits, so I would, however, recognize sort of the generosity of that and not immediately start hosting for 30 centimeter imagery service for the entire state of California on GitHub. I should say there is a rate limit to the amount that these things can be served out. So if you use GitHub as a data API, like if you want to bring a feed of GeoJSON from GitHub into a ArcGIS JavaScript API application somewhere else, there is a rate limit to the number of times you can ping for that data. And I think it would probably restrict you from a high traffic application. That said, I don't think any of the potential applications that I can think of in the state of Vermont would meet that traffic threshold. That's a good question. I actually don't know. So can you get a larger limit than 100 megabytes if you pay cash? As a person who works for a company that pays cash, I think the paying of cash pretty much only gets you private repositories, which are very useful in themselves, but I don't know that it increases your limit. So for sharing the website, is it just to show static layers, or can it be interactive to have user, viewer make choices of inputs, push out to a computer, and rerun an analysis? Absolutely. I simply showed a very basic application that was just to display those layers, but anything that you can think of that you could do with Leaflet, with open layers, with ArcGIS JavaScript API, all of that interaction can be built into an application hosted on GitHub. That said, it is meant to be thought of as a static website, which I guess broadly means like you don't have a server on the back. There are a bunch of sort of intricacies to that distinction, but I have not found it a limitation to interactivity to have static only data being served by GitHub. If you need to set up GeoServer, if you need to set up post-GIS, that's something that you do need to do elsewhere. GitHub doesn't support that. On uploading data and code, I'm working within Google Earth Engine API where the code is stored in Google Earth Engine that are accessed with links. Is there a way to use this code in GitHub as a shareable script that my team could work on simultaneously? Potentially. I'd probably need to hear more details about that. I've also worked with Google Earth Engine, and that's fantastic in its own right. But I think they're less concerned about versioning and collaboration. Although I guess there are certainly collaborative tools there as well. But what I would do with this is more likely move the data to GitHub and serve that data into the Google Earth Engine environment. The data that let's see, are they calling it Google Maps Engine these days? The GIS on the web thing that they just launched?
Yes.
Okay, so Google Maps Engine is sort of another beast, but Google Earth Engine, the remote sensing and analysis platform, I think it would probably be best to do it the other way around. So using GitHub hosted data in Google Earth Engine. Let's see. Yeah, GitHub is a for-profit company. That's a good point. They, as far as a change in their terms of service, they're not a benefits corporation. So there's no, I don't think there's anything legally binding on their terms of service. But the way that I've seen them comport themselves, they've actually turned down huge quantities of venture capital. They're not a publicly traded company. They are very narrowly focused on enabling an open source environment, and as a result, they're a for-profit company that has taken a very small amount of investment. The last I had seen, it was, I think, something on the order of $5 million from a firm that had agreed specifically to their terms of openness. That said, man, I don't fully understand the business end of it, so I don't want to rule out the possibility that they could be, purchased by some evil overlord and immediately closed down. But at that point, we'll figure out something else. So performance of data served from GitHub, it is crazily performant. A page hosted on GitHub Pages is actually one of the most robust things you could have, and it's because they enforce the static provision. So without getting into too many details, I've had thousands of concurrent users with no performance slowdown on an application that I've hosted on GitHub Pages. Let's see. Yes. So in theory, a government model where users use ArcGIS Desktop to edit could, with a plugin, use a GitHub repository to centralize their work and pipe it to a GitHub app that could be edited online and authenticated if we're willing to pay for that. And we're missing something. Joanna, awesome question. That is, well, yeah, good point there. The former CTO of the FCC, a guy named Mike Byrne, actually built exactly the plugin you're talking about. And again, that's my bad for not including it in the links. I will add that. But it's basically, as I understand it, it's basically a toolbox package that allows you to convert to Geo JSON very easily. I think he included GitHub syncing as well, and that was because I think in his case the FCC was very forward-thinking in data management, but they were also still very attached to the editing tools that they had. So I think that model already exists, and I'll include the link after we're done. Any good tools to shard vector features from a data set of smaller sets with geographic compactness a la tiles? Yes. Actually, the tool I last did a webinar about called Mapbox Studio does a great job of that. You can bring in a data set and then create basically a series of vector tiles. So using exactly the same tiling scheme as the imagery we're used to, it chops up vector data into those bite-sized packages. There are a bunch of other alternatives for that because it's getting to be recognized as like a web standard to do that. It's good practice, but they're escaping me at the moment. I will look into which ones they are. What's a good workflow for working with master and GitHub Pages branches? Do changes in master automatically show up in the GitHub Pages branch, or is there a process for updating the GitHub Pages branch from the master? Awesome question, and let me show you. There is a merging process. In this case, I should have just simplified things by not having, by not even having a master branch. It's not, strictly speaking, necessary. But it's what you always start with, so fairly straightforward. So this is, we'll go back to the changes. You can see nothing's been changed recently. These are the branches of my application, or they're the branches of my repository. If I want to bring the changes that I made to the GitHub Pages branch into the master branch, I just drag GitHub Pages up to here, and then drag master up to here. Direction of the arrow is bring the changes into this one, then hit merge, and then sync, and then that's it. So the master branch is now caught up with the GitHub Pages branch. This is something, this merging workflow is something that comes in really handy in software development, but is, you know, it's particularly useful for managing your GitHub Pages branch. Let me just see, were there other questions there? I was told Google Earth Engine is dead. Oh, I wonder if they deprecated it, but Google Maps Engine is all web-based. It's the same. Yeah, Google Earth Engine, I actually just used it for some client work back in May. It's a really awesome remote sensing platform, and at least at last use, it involved, like, you know, you could do really cool things like run random forest classifiers on Modis data and things like that. Oh, looks like somebody actually linked Michael Burns' tool here. It's called Esri2 Open, and you can find it on GitHub. Let's see. We're using this successfully to export Esri data to Geo JSON for hosting on GitHub. Cool. Hey, thanks for sharing that, Sean. I will add that to the presentation there. Anybody have additional questions?
Bill, I just want to point out way up right at the end of people commenting about who they could hear. Janelle put a question about what's the tinyurl.com the speaker mentioned. So somewhere at the beginning of your presentation you referred to a tiny URL.
I will bring that back up. There, tinyurl.com/vcgi-github.
Great, thank you very much.
Yeah, and again, that'll basically run you through everything you need here. You can links to sign up to a GitHub account, get the GitHub application, fork the repository that I demonstrated here, and functionally serve your own little viewer application. So yeah, you should.
This is also the link. This is the link that I'm going to include that gives everyone all these slides you just did and the links, as you just said.
Yeah.
Yeah. Okay, great. So
it's meta. That's the link to the link.
Yeah, and it's in the slides.
Yeah.
So I should mention to everyone, I think I forgot to mention at the beginning, that I will include this link. It will be posted both in the description of the YouTube video that's posted on YouTube, and I will also post it back at the VCGI website. If you click on Events and then Event Archive and then Webinars, you'll see a listing for this webinar, and it'll include the link.
Cool. Hey, thank you very much for hosting, Leslie.
Thank you. And again, I'm sorry, despite our best efforts, the beginning was a little bit rough, but hopefully people didn't miss too much and I didn't dither too much.
Yeah. Sorry, I'm already making that edit to put Michael Burns' Esri to Open package in there.
Great.
But yeah, hey, thanks again, guys.
All right. Thank you, everybody. And feel free to pass any additional questions on either to Bill or to me, and I'll pass them along to him. Thank you very much. Have a good day, everybody.